Hi, welcome back to another NIME's hands-on session on NLP. NLP stands for Natural Language Processing. So, as the name says, it is the way of enabling the machines to understand natural language. So, for this to happen, we need to convert the text into numerical format because the machine learning will models will need numerical format. So, in this session, let us see how this process is done with the different steps that are involved in converting the text to the numeric form. So, without any further ado, let's get started. In the interest of time, I have pulled in all the notes that are required for this model building. So, let's get started. So, our case study for today is going to be a data source where there is a film review from IMDB, which needs to be processed to understand the sentiment of the review. So we look at the review comments and see what is the sentiment of the review. It is positive or negative. So we read because the data is again in the tabular format. We have used a CSV reader and configured our data source. And as I mentioned, this is a IMDB data source where the review comments of the respective films are recorded. So the URL of the data source, the text which is the input here, which is in the text format. This is nothing but the review of the film and the sentiment attached to it, positive or negative. Okay, this is the data that we have in our data source for now. So let's see what are the steps that are needed to in the NLP processing. So because now this the first step is to convert this text into a document. For that we are using a string to document node. So by using the string to document node, we are converting each row. The each row has got a review comment, right? So each of the review comment is getting converted into a document along with the metadata. So the metadata that we are choosing is the text that is anyway there, and we are including appending the URL, the sentiment, and the timestamp and the document type, and also we are using a word tokenizer, which will help us to tokenize the sentence words in the sentence. So we have applied this configuration, and let's execute. If you see here, now, this data source has got the data that IMDb film reviews that we have are of 2000 records, and then there are four columns. Now that with one being the URL, text, and the sentiment. Now that we have converted this into a document, we got another data type got appended, which is nothing but the text document. The data type is text document, and all the information that is present as columns in each of the row got create converted into a text. So now we have 2000 text documents which are created because of this string to document node. Now, because the document, the newly created column is actually encapsulating all this data, we wouldn't be needing these columns from the data source. To filter out these columns, we are using a column filter. So we excluded all the columns and then we just retained the document because now this document is having all this information along with the metadata. So this is how the column filter is used for now, and we are executing this. So at this point, let us see how our data is looking like. After the column filter, we see that there is only one field because we excluded all the columns. We have only one field, one column, which is the document. Now, all the information that was captured in the table is being represented as a document for each of the row. So, we have in fact 2000 documents, and this is the only data source that we are going to use for the further processing. And if we want to see how this data in this document is looking like, we have a node called document viewer which will help us to do that, to look at this. So let's execute the document viewer and see how the data looks like. So now this is the document that we have with all the information. So to see what is there exactly in the document, we can double click and then see all the review comments that are there. Okay, so now, from a tabular format, the review comments have been captured to a document, and we have seen how the document is looking like. Now, let's get started with our important step of pre-processing this text. So, for this, I am connecting the column filter to the punctuation erasal. The first step here is we are removing the punctuation. How do we remove that? We pass on the document. Now the column filter has the document as the one column, right? That is being passed on, and that is being processed to remove all the punctuation, and a new column gets appended, which is the pre-processed document. Let us apply this configuration and execute. So once the punctuations are removed from the text document, now we are removing the numbers. Any numbers which are in the review will be removed by using this number filter. Once the numbers are filtered, we will use the ncar filter to remove any of the words which are less than 3 characters. So any words like in, on, those kind of words, is, those kind of words will be removed by using ncar filter. Now once that is done, that is done, we will connect it to the case converter node to convert the text into either uppercase or smaller case. In this case, we are using a lowercase conversion. So all the text, review text, is now converted to lowercase. Now stop word filter is filter that will help us to remove the commonly used words, like the common conjunctions like and, but, here, there, those kind of words get filtered out by using a stop word, because these words are not actually giving a lot of intent. It is not actually giving the intent to the review that we have in the text. So let's configure this, because our text natural language that we have right now is text, right? That is why we choose English, and we have executed. And the final step of text pre-processing is using a snowball stemmer. This is another kind of lamentation where the original words get replaced by the root word. So generally, every word in English has got its own root word, right? So those words get so the original text gets replaced by the root word. So the popular snowball stemmer is Porter, so we are using that for now. And let us see how our data got processed from how it was to how it with all this pre-processing. To see how the text review has been changed, we are again using the document reviewer to look at the content of the each document. So, just as a reference, let us take one sample record before processing, and then let us compare it now. So if we have taken a 100th row, which is like 100th document or 100th review that we have from our source, and we see that now this is like there is a review of on a film which is based on teenagers and some stars, and now this review comment is almost of eight lines, and there are a lot of punctuation marks, question marks, and then a lot of text and capital letters and stuff like that. So let us see how this 100th row document got transformed after this pre-processing bar. So let's go back and see how our text looks. See, now the 8 lines review comment has been shortened to 3 lines, and because of the stem words, snowball stemmer, we see the root words like story, teenage, disturb, movie. So all of these are the root words of the respective word. And we also see that all the punctuation marks, the numbers, the conjunctions, and verbs, all of them got removed from the text. So now we have done the text pre-processing, and now comes the second important stage, which is text to numeric conversion. For this, we are connecting the source back to the bag of words. So what bag of words does is it collapses the sentence structure, and then it just changes them into a bag of words. So let's execute this. Once this is done, let us connect it to the term frequency. So what happens in term frequency is we calculate the frequency of each word. Now, how frequently this word is being used. So that is what is being captured as part of the term frequency. In the bag of words, sorry, I forgot to show you the output. Now, this is quite different from how the transformers work, but because transformers are very complex, for the sake of simplicity, for now we are using the bag of words. Number of columns, the number of rows have tremendously exponentially increased. The original data that we had here that was given to the bag of words is 2000. Because there are 2000 review comments, we had 2000 rows, 2000 documents, so on and so forth. But now, because each review comment got transformed into a bag of words, now we have literally 1,63,000 rows. So every word is now represented as a row. So this is what is the output of the bag of words. Now with the term frequency, now we are going to see how many times this each of this word is being used in the whole of the review set, right? And based on that, a frequency has been calculated. So that is going to be the output of the term frequency node. Now you see a new column has been appended. With bag of words, we got in every node has become a row, and now with the term frequency, we are able to see how frequently this word is being used in the whole of the reviews. Now, once this is done, we are going to connect it to the document vector. So this is where, now again, this will take some time. So this is where node where which will actually convert the text to the node numeric format. Now each of the word it gets represented as in the numerical format. Let us see the output of this once this is executing. It is taking time. It's loading. Yeah, you see now again we are back to 2000 rows, but now this time each of the review is being represented like now, all the words like the bag of words which were as represented as rows became like columns now. And now for each of the column we are able to see if this word is being used in the review or not. If the word is being used in the review, we represent it as one. If it is not, it will be represented as two. So this is how the text is being converted to numeric format. Okay, so what we have done, we first, so until this text pre-processing, though we removed punctuation, numbers, and all that stuff, removed small words, everything was in still a text format. With bag of words, the text became the just set of words. And then we applied a term frequency and we identified what is the frequency of each word. And then we have gone back to each of the review and represented that word with that frequency. Now that is how we got this each of the row back. Now this is the document vector where the text is being represented as a numerical form. Now this is being passed to the class category to class, because now the review is, now we have achieved our goal of converting the natural language English into a numerical form which will be used for machine learning. Now because we are dealing with a classification problem, and then we have this label which is called the category, which is sentiment, which is helping us to identify the review comment is positive or negative. We are going to append this to the our numerical data that we have converted this whole text into so far. Once that is done, now our data set is like ready for like any kind of a supervised learning data set, where we have set of input features which are in numerical form, and then a labeled data that we will be using for a supervised, by using any kind of supervised learning we will be able to train the model. So in our case today, we are going to use decision tree for this whole process. Okay, now we have appended the, um, we have, if I just quickly show you, this is going to take time, but if we just look at the document vector, how many columns are there? You see there are 26,307 columns. Now we have appended our label also to this column, and let us see how many columns. Now, because of this one label, that category classification label, we have 26308. Okay, so now this is like a typical structured data set that is eligible to be passed on to the model training. So now here on, the process is similar to what we have seen in the previous hands-on sessions. So we already have a detailed video on decision trees. Please watch that. For now, for the interest of time, I'm quickly going through. We'll convert it to the table partitioner, which will be doing a 73rd bit partition. and creating a training and test data set, and then we will use the decision tree and configure the decision tree with the MDL, which is like the pruning method. And we are having we are going to build a decision tree. Once the decision tree is built, we will be using that for prediction and on a test data. Once this is done, we will use the numeric scorer to evaluate the performance of the model. Now, with the help of scorer, we can see the confusion matrix, the accuracy, and the FN score of the of the model, just like any other supervised model that we have seen so far. In case of classification problems, these are getting queued. I mean, they are getting processed. So let's do a quick recap. How did we reach here? We had our IMDB film reviews captured in a text format, in a tabular form. That is why we have used a CSV reader to extract the text, convert each row of the review into a document. And because now the review document has all the information, we have excluded all the columns that were initially present in the table, and we have seen how the data looks like in the document format. Now we started with the text processing, where we remove the punctuation marks, we remove the numbers to remove the small letter words like in, on, those kind of words, and then we use the case converter to convert the whole text into the lowercase. We use topword filter to remove some common words like conjunctions and stuff like that, which does not really add much meaning to the whole of the intent of the sentence or or the review. And then we used a snowball stemmer to refer back to the root word of the words that are text that is being used in the review. So once this pre-processing is done, we saw that how the text got transformed from the way it is presented to us, and then with help of the text pre-processing, how we have converted that text. Now the next stage of this whole NLP would be converting this text at this level into a numerical form. So this is done using the bag of words. By with help of bag of words, we collapse the sentence into just a bag of words. Now the sequencing impact much. Uh, uh, does not impact much here. We just wanted to collect all the words that are there in the review. So once this is done, we use the term frequency to identify how frequently this word is being used in the whole of the reviews. So once the term frequency has been calculated, we used a document vector to represent each word in the review with the frequency that has been captured for each of the word. So with this, we actually finally could convert the text into a numerical format. We appended the label on the we appended the label sentiment, so that now the data is available for the machine building. We are use now this text we have here. The input features are the text of the original review text got converted into the numeric form, appended a review label, I mean the sentiment label of positive negative, which is also part of the original text. Okay, so now the data set is now readily available for further used for the machine learning. So in this case, now we went back to our decision tree, split the data into 30-70 partition, used to 70% of training data for decision tree building, and then used a predictor to test it, and used a scorer to evaluate the performance of the model. Now the all the nodes have been executed. They are in green, which means that they're all executed. Let us see how the scorer is helping us to see the confusion matrix. So this is how the confusion matrix is looking like. Let us see the statistics. The accuracy of this model is like 89.7, and it has got a good F1 score as well. So this is how we have the original text got transformed into a numeric form, and then we use the decision tree to for the model training and building. So this is where how our NLP works. Thank you for watching. See you in the next video.